afterwards.
Yeah.
Recording has started. There you go.
Oh,
All
okay.
recording now.
Oh,
Well done, that's it.
fantastic. You're now full screen.
I'm now full screen.
Yes.
Fantastic. There you go. All we had to do was record the session. Who would knew that Skype works like that? It's the things that we learn every single day. And trust me, I'm on Skype every single day. I don't think I've ever experienced this one. So anyway, can you guys see this better now? Is it much better?
Yes.
Awesome. Okay, good. All right, brilliant. So let me kick off my slides, which I think I've ruined the surprise by having it like that, but fine. And I will explain why the hammer is there. So today, thanks for inviting me, first of all. Thanks, Dave. And I'm really gutted that I can't be there in person. I was actually in Bristol just last night. I was going to see a customer today and then drive all the way up to you guys and be there. Unfortunately, my wife called me last night saying that our two daughters had chickenpox and one of them had a cold as well, so double whammy. And I drove up from Bristol all the way to Glasgow to be with them. But I made a promise and I didn't want to not keep my promise. So while my wife is tending to our two lovely kids, I'm here with you talking about the other thing that I'm very passionate about, which is Azure Serverless and mobile apps. So thanks to anyone that could make it, and for those that didn't make it and you're watching the recording, I hope you enjoyed the session. So I was at a user group some time ago when I early on into my speaking career. So thanks, Dave, for supporting me into that. And the reason why I have the hammer there is because most of my team that I work at Microsoft, they tend to say that I use functions as a hammer because for every problem, I find a solution with a function or a logic app, and I will explain what they are if you've never seen them before. So, Dave, you have to relay that for me, but how many people in the room know about Azure Serverless, and how many of them used any of the serverless features like logic apps and functions? Raise of hands.
So people know about it. One person tried something with functions. I've tried both, obviously, but yes.
Okay, brilliant. That will make it even more impactful today. Fantastic. So, quick introduction about myself. I tend to keep that slide for the end, but I decided to put it here. I work for Microsoft as a premier field engineer, and that doesn't mean anything to anyone. So, consider me a consultant, trainer, and problem solver. I tend to do a lot of things on Azure and off Azure, and I'm in the dev team, so we do focus a lot on development, and we help developers do stuff on Azure. I have done a lot of projects with serverless, and that's why I'm quite impressed by the serverless possibilities on Azure. And I'm an open source advocate, not just on Azure or Microsoft, but all things open source. Surprisingly enough, though, Azure Functions are fully serverless. And I have my email, I have my Twitter, and I have my personal blog. I'll share the slides at the end. Feel free to reach out to me if you have any questions after what we discussed today, or if you have any other random questions about Azure, feel free to hit me, or open source. And without further ado, once upon a time, many of you have probably worked in different teams, and I was fortunate enough at some point to work in a team where we were creating an application that was distributed to lots of our customers. It was in the securities, finance industry, so that was all fintech. And although we started as a web platform, we eventually moved into mobile, and we were probably one of the very first few people to use Xamarin back in 2008, when it was very early days. And what we quickly found out was the problem that we had very tightly coupled web applications that didn't really expose any of the data that we want to use for our mobile apps. And I'm sure if I were in the room and I said, how many of you create mobile apps? Most of you would say yes. And then the next question will be, how many of you create APIs for your mobile apps? And most of you would say yes, because most of the apps these days tend to be data-driven, and we want to drive rich experiences for our customers. And if you are a .NET developer, you have a couple of options. WCF, raise of hands, probably none in the room, and I'm glad to hear that. nothing wrong with WCF, but it's aged now quite well. So most of you will be doing web APIs or some kind of API kind of using MVC and web API. In the new world of .NET Core, we have just ASP.NET, which allows you to expose data in whatever manner you wish so. And some of you may be more adventurous, so you might be drifting into Node.js and other frameworks. And that's fine. There's no real issue there. But what I'm going to say here is that as I was working for that team as a .NET developer, we started creating web APIs, and that was nice. But the problem was that it took time. It took months to come up with the web APIs, the architecture, the design, the performance, the scalability, and so on. And these are some of the decisions that we were faced with, and probably you will be faced with, especially as your application starts to scale and you start to get more users. And these are usually good problems to have. If you start thinking about how am I going to scale my application, then that's a good thing because you have lots of users. But for any developer, that's a pain in the butt because they don't really want to think about how things should run on a server. They just want to deploy the code. And for the admins, it's usually the hardest part, understanding how things will scale, what kind of platform they're going to use. Is it going to be Linux? Is it going to be Windows? Can we run things on the chip, and so on? So a lot of decisions there. And usually that also fits into the time that it takes to actually deploy stuff on a platform. Azure made it quite easy with mobile apps. So I don't know how many of you have had the chance to work with mobile apps. It really abstracted a lot of that pain by giving you a very quick way to create backend databases and APIs that will wrap around them and dynamically work on those APIs. But it still had the same issue with regards to scalability, right? And because we abstracted quite a few things, you didn't really have lots of control there. Now, in the last year and a half, probably 2 years, Amazon had a head start with us with Lambdas. So they created this thing called a serverless framework where they would run functions called Lambdas. And the idea there is that you can upload your code somewhere, you don't really care where, and just run that little bit of code. And that was fantastic. And then we said, right, okay, we need to jump on the game. We actually need to create an experience for developers to make it more compelling and more fun. So we came up with the idea of serverless on Azure, which allows you to focus on how do you architect your application to become serverless, and how you can take the smallest piece of code that you need to run, and sometimes not even code, and actually run it on Azure. And that's the beauty of it. You don't care about what the underlying framework is going to be. You don't care about where it's going to run. So if you're creating .NET Core functions, it could be running on Linux or Windows, you have no idea. It could be running in a container, again, you have no idea. If you're creating nodes, the exact same thing, Python the same, so you don't really care about the underlying infrastructure. What you care about is how you're going to break up your application to run on Azure. And it ties really, really well with mobile because every mobile application will have a backend that needs to drive the application. And the problem there is how do you quickly set up and create an API for your application. So serverless it's beautiful for what it has to offer, and today I'll be focusing on the API perspective of serverless, but the possibilities there are actually quite a few, and you can solve lots of different problems with the serverless architecture. So when it comes to benefits, obviously I mentioned you don't have to care about your servers. They run somewhere. We maintain everything. We look after them. We water them. We feed them. All you care about is running your application. If you want to scale, which is the next icon there, we actually scale instantly. So there are two different models to run your functions or your code if you want to. And one of them is you prepay because you know that you're going to run something every so often, so you have predictable workloads. But if you run on the consumption model, we will scale out to as much as your pocket can afford it. So if you want 1 million instances running, I don't think anyone runs 1 million instances, but if you want, say, 10,000 instances running concurrently to process your IoT data and then feed them somewhere else, we can do that. And because we're actually event-driven, which means that we respond to events as they happen, you save those cycles. You don't have to run on a schedule, for example. And the simplest example I can give you there is if one of your users interacts with your application and wants to submit some data or look into some data, then rather than having a web API sitting there eating cycles and IIS running your process, what we're going to do is we're going to respond to that event that the users will instigate. And that's fantastic because not only saves you those cycles and the resources that you need to pay up front, but it also scales out because, again, you don't know how many users you're going to have. You can start with one, which is going to be very cheap, and then you can go all the way to 1 million. And again, you don't have to change a single bit in your architecture. And micro-billing. Now, this is very interesting, especially for mobile apps, because if you think about it, we give you 1 million events for free per month, per function app. So you create one function app. You can have 10 functions in that function app. I will explain what that means. And then we will give you 1 million executions there for free. Or if you're doing lots of heavy lifting and you're running longer processes, then we have this thing called a gigabit. So you get 400 gigabits. And a gigabit is a calculation. Weird names, I know, but it's not Microsoft naming. That's I think the industry standard. It's a calculation that takes into consideration how long you use the CPU for, how much RAM you used, and how long you run for. So if you're running, you're spinning up lots of CPU cycles because you're running heavy processes, then you're going to be paying more. So it's either 400,000 gigabits or 1 million. And for many, many customers, that means that they can run the whole infrastructure for free per month, because we reset every month and then we start again. So you are focusing on managing your applications, not the servers, not the backend. You focus on creating a very quick API for your mobile app, and you're good to go. You don't have to worry about, which version of Node are we going to use? Should we go to .NET Core? Should we go to Web API? What are the problems going to be? You don't have to think about these things. You go straight into adding value and solving problems. Reduce DevOps, and I used to joke early on in the days of functions where it was reduced because there was no DevOps, right? We didn't have a really good story around deploying your functions. Now we have full integration with CI/CD systems like VSTS. We have a very mature command line tool that, or we had one, and I'll explain why I say we had. We have a new version of the command line tools that have slightly changed and they were rewritten from scratch to allow you to run cross-platform. And for that, we took a bit of functionality out. But you can still push functions into your environment using the CLI, and we also have direct integration with source controls like Git or Bitbucket or VSTS, again, to allow you to deploy. And we have a very, very good developer story. It's not just the ops, so the deployment story, it's also the development story, where we allow you to create, debug, fix problems on your local environment, and then upload them somewhere. So you can do lots of work locally, even though you're using live backend systems. So you can use blob storage, which is live, and you can respond to events from that blob storage into your functions running locally on your own environment, and then propagate that event where it needs to go. And finally, it's faster time to market. Everyone is doing it, and everyone is getting on it, and it's the easiest way to create very complex architecture and solve problems with minimal code. And in some cases, it can be no code if you're using LogicApps, because LogicApps is just JSON. So from a business perspective, if you can create an API that takes a request and comes back with a response, and you don't have to write any code, and then that's a massive win because you have very low liability when it comes to risks and bugs and everything else. You deploy it and you expect it to run. If it doesn't run, it's Microsoft's fault. If it does run, then you're there. If we don't meet the SLAs, then you can come back to us and call us out. So when it comes to actually working, and when it comes to implementing your solutions for your Xamarin apps or for your React web apps or your Angular web apps or anything else that needs to interact with something in the backend, and many companies now are following the trend where they will create an API that does all the heavy lifting, and then they abstract or they leave the front end fluid because they don't know what they're going to be doing in 6 months or a year down the line, as long as they have the API to provide the functionality. So if you want to write code, or if you need to solve problems with code, Functions is your baby, because it gives you the developer tools, it gives you a full or a rich ecosystem with triggers and bindings that can trigger your functions. That's the events I was telling you about, but also output bindings. So imagine a request coming in, you process the code, and then you have a binding that will go and store the data into Cosmos DB or table storage or your SQL server without you writing any code. You just pass the object and we'll deal with that as appropriately. And you have flexible deployment options. So functions are brilliant. And they support lots of languages. So we have Bash, Bats, Python, .NET, obviously. .NET Core now has moved into full support, Node, and TypeScript. So if you like to write safe JavaScript, you can use TypeScript. LogicApps use predefined blocks. So you have conditions and you have events which allow you to put them together to create workflows. But again, you can solve the same similar problems. So you can have a trigger that is an HTTP request coming in, and then the logic app kicks off. And then you do something with the payload, like selecting a subset of the payload, and then passing it on to another function or another logic app, and then in the end, just sending back an HTTP response saying successful. So that can all be done with just logic apps, and they are just JSON blocks. So no code, no extra bugs or anything else. We actually have, I should change the number because I should say 200 connectors rather than 100 plus. And you can also create your own custom connectors or APIs that you can use to connect to things like FTP servers, your own on-prem server, your SaaS solution, somebody else's SaaS solution, ServiceNow, CRM, anything you can think about. Dropbox, Skype for business, everything. And it allows you to orchestrate functions as well. So you not only can you solve problems, you can also use logic apps to orchestrate stuff. And the new kid on the block is Event Grid. It was announced at the beginning of September to tie in with Ignite. So I don't know if any of you got the chance to watch the announcements of Ignite in September. But the idea is that Event Grid allows you to not only raise events, but also manage all the events that come from different places into one place. And you can have the built-in events that are part of Azure. So something gets uploaded into blob storage, you want to have an event exposed, we automatically surface that to the Event Grid. And on the other side, you want something to be able to consume that blob item. So we have bindings for logic apps and functions that will listen to that event in the Event Grid and say, right, I want to process that blob. So that's fantastic. You don't have to do any code. We've done all the plumbing for you. Near real-time delivery, broad coverage of services. We're adding more services as we speak, and it scales out infinitely again. And it also has built-in functionality for things like poison queues, or what happens if my first attempt fails because my backend code was not ready to receive it, or how about surfacing those events on your mobile app. Again, in the past, you would have to write complex code to do so. Now with Event Grid, you just need to listen to an event, write a little bit of code in .NET or Node or whatever you want to use, and that will also be available. So you can have bidirectional events from your mobile app to the backend, and the backend to the mobile app, and every other service you use in between. And around them, we have things like databases. So SQL Server, MySQL now fully supported. You can use PostgreSQL, or you can use Cosmos DB if you want to have something like a NoSQL database, or whatever custom NoSQL database you want to have. The storage accounts as well, obviously very vital for storing blobs, and table storage for structured data. Access and security, full integration with Key Vault if you want to securely manage your secrets in your application. IoT support as well, so the ingestion and support of hundreds of thousands of devices around there. We will ingest them through the serverless platform, analytics and intelligence at the back of that, and obviously the tools. So as a developer, you care about how you're going to do these things, and you don't want to be doing them on the portal. I'll do a very quick demo on the portal, but obviously this is not the proper developer experience. This is me playing around, having a feel about how functions look and what they can do for us, and then moving into proper ID. So we have Visual Studio support, absolutely, but we did say that it's cross-platform, so Visual Studio doesn't run anywhere other than Windows. So we want to have support for Linux and Mac. So if you are doing .NET Core, and if you're doing Node, for example, or TypeScript, you can actually run Visual Studio Code, which will allow you to debug into your code, see what happens, and then carry on with the execution. So proper ID support across all platforms. Integrated DevOps, we have the CLI, we have VSTS. The local development means that when you run your Azure Functions, we actually give you the Azure runtime engine that we run on the portal on Azure. So when you run things, and I will show you how that looks like, we actually spin up the engine behind the scenes, and we host the functions in real time on your local environment. Monitoring, we added support for App Insights. If you're not using App Insights, please fire off an email to me so I can send you the links about how you can monitor your applications, not functions alone, but any application other than mobile. Unfortunately, for mobile, we spin off another logging engine, so you guys know that in the mobile center. But for anything else, web APIs, desktop applications, WPF, WCF, everything, we do have App Insights to monitor. And functions have deep integration now with App Insights. And finally, we give you a visual debug history, which I think will move into App Insights or will go away from the portal altogether, because we have much richer integration with App Insights now. I think some metrics very, very quickly. Boeing is doing 11 billion executions per month. Just to show you how mature the traffic is, the platform is, and we're not making these up. These are real customers that are running production workloads on the Azure Functions platform. 560 million is the next second one, so you can see a massive discrepancy there. But we're having lots of customers now that are really invested into serverless. So if you're thinking, is it mature enough for me to run? Am I going to be able to run stuff? Stop thinking about that. We have massive companies running them all at extremely high loads. And with that, I think the next one is just some scenarios. Real-time stream processing, so IoT stuff or any device that send data. You can feed them through event hubs, and then obviously at the back of that you have your functions and your serverless and your LogicApps and event grid, and then eventually something to store it. Timer-based stuff, very simple thing right now. Imagine if you run everything on Azure and somebody said, oh, we need to run a task that runs every midnight, and we want to send emails to all our customers based on some criteria. In the past, you would actually have to have a VM where you create a daemon that wraps around your application to run it every so often as a service, or on a Windows environment, you'll be doing that as a Windows service. On Azure, we don't really have those services, so the easiest way to do it and save loads of money, loads and loads of money and pain, is to do it with serverless. So you can say, I want to run a Logic app, or I want to run a function at a specific time, and you can use cron to define how you do that. So maintenance tasks. Mobile app backends, I did speak about that. So APIs, fantastic way to create these things, and I will show you how with a demo. And real-time bot messaging, so everybody's doing bots, and we want people to be able to interact with the bots. And the easiest way to do that is, rather than you spinning a lot of infrastructure and a lot of VMs or code to do that around your work, you just use functions. And there's lots of examples out there that you can go and jump into GitHub and see how we managed to do the integration. So, unified API surface with API proxies. So, before I do that, I want to jump into a quick demo. So let me just stop that there. So for many of you have not really seen how functions work or how they look like. So in the portal, you go and create something called a function app. So this is a special kind of resource, which is a function app. And function apps are web apps. So technically what you get behind the scenes is actually a web app. And you can see that by, if I go into, how did that happen? I did not go there. So if I click on my function app, and if I click onto the one I created just now, because I want to save some time, if you go into platform features, then you will notice that some of the settings here look very similar to the web app settings that you get. That's because we run on top of an app service plan. Consumption model, which I mentioned, which scales infinitely, it's a special kind of a service plan that doesn't have any limits. So it runs on our own infrastructure. Everything else is running on, so you can say, I want to run on a premium tier or a basic tier, and that's absolutely fine. You prepay for your resources, but you have to manage scalability. So that's the challenge there. So with the function app, I don't have any. So the function app is a cell. It's used to hold your functions, and in here you can go and create a function very easily. We give you a guide. So if that's the first time that you're doing functions, actually, I would encourage you to come and use this one. You'll notice that out of the box we have support for C#, JavaScript, F#, and Java, but you can actually use the advanced editor, which is not a quick start, and allow you to go and do lots of different things with lots of different languages. Languages here, I mentioned all these, and for scenarios, you can have lots of different bindings and triggers that allow you to do things. So I didn't mention event grid integration. So if you come down here in the experimental, you'll see we have event grid somewhere down here. There you go at the bottom. So I might be jumping in and out quickly because of the lag there. So I'll keep this a little bit. So we have event grid trigger there for both C# and JavaScript. Okay, and external tables, external files, there's loads of triggers that you can use. And in fact, we have an extensibility model now that allows you to go and create your own bindings if you want to. So if you have an application that you want to integrate with inside your an enterprise environment, then you can do so by creating your own extension. Now, enough with fluff, let's go and create a function. So I'll use a webhook only because that's the easiest and fastest way to get started. And from there it will just open eventually, and it will actually pre-populate. So it uses a template to do that, and we have the exact same templates on the CLI or the core tools as they call them, and we have the exact same thing on the portal. So it's same consistency. And what we're doing here is we just say I'm expecting a request that will have either a name parameter or in the URL parameter, or it will have a name inside the body, and then I will take that and then return back a hello name, whatever. Okay. And right now we have the function there. I don't need to do anything. I can actually go and run this thing, and it will run fine. We have our own running engine in here, and you'll notice that down here we have the results showing up. We even create our own custom. We have some payload there, dummy payload to run things. So if I want to change stuff, I can go and say hello Birmingham. I think I may have butchered the name there. So there you go. So down here you'll see I've changed that. So instant changes, and that's the visual editor that we said. So if I do something and I break the code and save that, it will compile on the fly, and then it will fail it because obviously there you go, compilation failed down here because my code is not compiling. So you can see you can very, very quickly get off the ground without really doing anything, right? And imagine if I said, right, I can actually go and bind directly into my database now and have an API that accepts a message and then puts it into the database and then returns back a 200 success. And that's all it takes to actually create a one API endpoint. Now, I really like this approach because considering how you might need to scale your application in the future, it's individually scalable, right? So you can have one API endpoint or one function getting 10,000 requests, but you can have all the other API endpoints only getting 2 or 3 hits a day. In the past, you would have to scale the whole thing in one go. So your web API will have to be deployed on multiple servers to do that. So that's a waste of space, that's a waste of time, that's a waste of effort. Whereas here, we just focus on what we need to do. So that's an HTTP request. So an HTTP trigger that comes in and goes out and does things, and that's fantastic. Now, there is a thing that I mentioned earlier on, and hopefully you're following me at this point. If I jump back onto my slides, I talked about the unified endpoint with API proxies. The idea there is that we give you a proxy that will be the single point of communication when it comes to your APIs. So your APIs for your mobile apps can live in multiple places. You can have API endpoints that run on Lambdas on Amazon. You can have some API endpoints that run on your on-prem environment that you want to expose. And then you can have some APIs or API endpoints that are running as part of your Azure Functions there. What I can do is I can actually create a proxy that will act as the unified endpoint. And then when it comes to exposing that to your users or your application, you only have to worry about one endpoint rather than remembering 20 different endpoints for your every single individual API endpoint. And not only that, but you can do some clever things. You can do string manipulation. You can do some wildcard matching, and you can also do dummy APIs. So I will show you that in a second. But some of the challenges that we are trying to tackle here is how do you design your APIs how do you control your API surface in a single place rather than having lots of different places? So if you create a proxy, then the authentication will take place in the proxy, for example, and that's what Easy Auth is all about. In web apps and function apps, you actually can implement Easy Auth, which gives you a very easy way to add Google logins or social media logins or even Azure AD logins without having to write any plumbing code for that. And you can modify the request and the responses to match your backend. So imagine one of the examples I will show you is I'm speaking to a third-party API to get some movie reviews at the back, and I'm using the New York Times. Well, I don't want to expose to you guys my key to the New York Times, so my proxy API does not mention anything. It just says, give me a movie name. But the back end, I'm passing the movie name plus the key, so I'm actually modifying the request and the response. And you can implement APIs in a serverless model, and we give you lots of tooling inside Azure Functions to do that. And we also provide you support for Open API. So I don't know if you guys know Swagger or heard about Swagger or Open API, which was the new name for Swagger. It's more or less what you would get in WCF, the WSDL file. So we expose an Open API definition file, which is a contract that describes how your function is running, or how your API is running. Sorry for that. And it gives you things like what kind of expected payloads you should have, and what kind of expected responses you're going to be getting. It allows you to create APIs. Now, this is interesting. If you guys are using Visual Studio, you can take a Swagger API definition and copy it into your Visual Studio and then say create API code at the back of that, and will allow you to, with one right click, to create all the code that will be consuming that specific API. So if you're writing a mobile app, you can actually go and create all the endpoint codes to communicate with your API without actually writing any code. So that's very powerful. It creates all the plumbing for you. And without thinking, I have my first demo. So if we go back into our into this environment, I already have created one that I used in the previous example. So I have a proxy here. So let's wait for that to load a little bit. The team is doing work to actually speed this whole process quite a bit. So I think it's the first time I'm hitting this one. That's why it's taking some time, because it's warming up. If I go back to my previous example, you see it's already there. So let's see. This one is still loading. So there you go. I have a proxy here. So if I show you that, so my awesome API. So what I have here is I have a hello world or an HTTP trigger. I think it's the same thing. And the proxy works in this way. You have you define the proxy name. So you say I want to have a proxy called weather whatever, and then I want the backend URL to be the actual API endpoint. And when you save that, it will actually create the proxy URL that you see at the top, the HTTPS, the public DNS name that you want to expose. Now you'll notice I'm only passing city, or I'm only expecting city in that URL, but further down, my backend URL uses the app key to speak to the API itself. I'm never exposing that to any of the users. So I've done 3 or 4 endpoints here. I have one that takes movies, one that takes your name and it says a hello world, so that was the one that we wrote earlier on. I have one that looks into the weather, which is my awesome API. I should name it something better. But also I have a mock one. Now this is the most powerful one. Imagine if you're creating an mobile app, but you don't really know what the backend will look like yet. You just want to be very fluid and not have anything there. What you can do is you can actually go and create a mock API endpoint, no backend URL, but you can edit the response to return whatever you want. So you can very, very quickly go and create mock APIs for your mobile apps without actually using any code. You just define the JSON down here, and you say, I want to return that. It should be a JSON return at the back end, and it should return success. And you can also do failure if you want to, so there's nothing stopping you doing that. You can also change the methods that you're going to be calling, so you can say I want to have selected methods that I'm only accepting. So if you're writing tests or if you're writing integration code, then that can all be managed through there. And that's it. So if I were to run this one, I'm not going to save this. If you do any changes, you need to save stuff. if I were to execute this one, there's lots of different ways to do it, but if I come here and paste into my browser, just grab the URL. So that should return some, there you go, so that returns my data, which is the same one I had in my request override, response override. There it is, easy peasy. So you can actually go and create your mobile apps without really writing any code in the API yet. Or you can have a different team working on that, but they're not ready yet, so just like that. Now if I go into the, I want to continue, I don't want to save anything there. So if I go into my movie name or my movies API, now you'll notice that the endpoint here is Tech Days Proxy, Azure Websites.net. The next one is exactly the same, it just expects movies and movie names. So I'll use my favorite one, which is Deadpool these days. We watch this with the kids. I'm just kidding. So there you go. That's the review. Now, this is my unified endpoint here. I haven't changed that. Nobody knows where I'm implementing that. But what I'm calling in the backend is a New York Times API that returns me the data. And you can think that you can have already API sitting in your on-prem environment that you want to take advantage to use, and you don't want to rewrite, or you don't want to move them onto Azure. That's absolutely fine. We can communicate with them through the proxy, and that's brilliant, right? You can have your API sitting anywhere you want, and allows you to very, very quickly put something together to consume. You can also expose that to your customers. It doesn't have to be a mobile app. I'm just using mobile apps because I know that you guys are focusing on mobile applications at the moment. Next one is the very tight indication we have about security and sharing. So I did mention that earlier on, and I did say that you should be able to do that, and we do give you the ability to do this. So if I'll say I don't want to save those changes. I'll go back into the platform features. Some of the new stuff that we added is managed service identity. If you haven't seen this one, it allows you to communicate with your backend databases or key vault or storage account without really defining any keys. So we will create a specific identity that is only allowed to communicate between your functions or your web apps and the backend, and they have very specific permissions. So that takes away the risk of actually exposing sensitive keys into your code. But the two important things for API definition is the API definition, obviously, and the CORS, which is the cross-origin resource security, which means that if you want to whitelist only specific items to access your APIs, you can do so. But the API definition is the one that we talked about, the Swagger API. I don't seem to have one. Oh, there you go. There you go. I have one empty document. It's trying to think about it. So the first time that you access this one, it will ask you to generate the API based on your functions. So if I zoom in here, it will say generate API definition template. It will look into your functions. You don't have to write any code for that. And we'll come and create that thing in the middle over here that you see. It's called Swagger 2.0. And this one actually describes the stuff that we were talking earlier on. So my weather API endpoint, my so the head over there, if you scroll down, you'll see we have the movies and what we expect to do there, and obviously all the verbs that are supported, and my say hello API. And if you expose that to your users, you can expose that endpoint here. You can say, oh, if you want to test my API, just grab this URL, come in here, and then when they do that, they will have a play area that they can come and try an operation. So they can come in here and say, I want to try, no, we haven't defined anything there, but if I want to define a city, so it should be London, and I can actually go and run it. It might not work. Make sure the server technically accepts GET requests. So I haven't defined that. That's why it's not liking it. But exposing that means that not only you can let other people test or other teams within your enterprise test things, but you can also take that, put it into Visual Studio, and boom, you can straight away have an API created or code created to consume your API. So that's very, very powerful. I'm going to leave some time in the end for questions, so I just want to make sure we cover quite a few things here. So that's the browser experience, which is not very dev oriented, but you can do the exact same things from the command line or the CLI tools or Visual Studio. The reason why I'm not using Visual Studio is because we tend to promote cross-platform, but I think I have Visual Studio, or I had Visual Studio open. Let me just fire up Visual Studio just to show you what the experience looked like. But for now, we'll focus on the CLI. Can everybody see that, or should I make it bigger?
That's fine. I can see that.
It's fine. Okay. So let me clear this. Sorry, two different operating systems, and they have different commands. Fantastic. Right. Okay. So the first time you install your core tools, which is an npm downloadable or Node.js npm downloadable installable executable, you get the func runtime, and when you click on that, spins up things very similar to what other command line tools do. So .NET Core, if you use .NET Core, you'll find the same with .NET. If you use npm, does the same. So func does that, and you know it's serious because we have serious ASCII art. We spend months doing this, so rest assured that we look into quality, not just quantity. So let me just go into my play area, which is CDC projects. Make dir. So I'm creating a directory now, so we can go and create a function with the CLI. So make dir berm demo. What? Oh, I need more coffee, or it's too late for coffee. So let's see, let's that one. Now func init. If you are versed in the world of Node, then you know that func init is very similar to npm init. So we go and create our function app. The very similar thing that we had the cell inside our portal, right? And then we don't have a function yet, but we do have things like a host.json, which is only valid for the production environment. We don't look at that on the local environment, but we do have a local settings.json. So unless you're doing, if you're doing anything else other than HTTP triggers, then you need to define a storage account. If you don't define the storage account there, just forewarn, you'll get some weird error messages. You have no idea what they mean, and all they mean underneath the scenes is actually you need to go and define your storage account. So always have that in mind when you do local development. Launch.json is for our Visual Studio, and I will show Visual Studio code. I will show you that. And now here I can go and let's say func new. And straight away you'll be presented with only two options. And people go, what? Chris, you've been talking about all these different options, but we only get two languages. And the reason for that is because we rewrote the tools from scratch, and we had a deadline for MS Ignite. So the first two languages were the most popular ones that we added, so C# and JavaScript. Everything else will follow very, very soon. So rest assured that everything is there. You can still create functions on the portal or other environment and import them here if you want to use a different language. We can still run them. It's just the fact that the templates have not been updated. So in this instance, I'm going to use JavaScript. And for the trigger, again, we have tons of triggers, but I only have 4 here. Again, the exact same scenario. I'll go with an HTTP trigger. I'll name it Hello World. And that's it. When it created our code, it created a sample data file and also created a function.json that defines that. Now, not everyone likes the command line, so let's jump onto our VS Code. So imagine most of the time I run these demos, I run them from my Mac, and they run exactly the same way. So there's nothing really different. It's the exact same consistent experience. We have the launch.json here that allows us to actually attach to Azure Functions as they run. Check this out, Java. We just added support for Java, by the way, in case you didn't know. We have the code, which is here. That's our function. Sorry, let me make that bigger. So that's our function here. You can have multiple functions inside your function app. Think about it. So you can have an API as a microservice, or you can have a single API per function app. You define or you decide how you want to run them in terms of deployment. I think I tie them usually like that. This code does the exact same thing as our C# code, which goes and says, find me the query parameter. If there's no query parameter, look into the body, If there's nothing in the body, then send a 400 error. If there is one, then say hello and respond back. And as I said, the localhost JSON, it has a dependency there for the storage account, which can be left blank only if you're doing HTTP triggers. Everything else requires a trigger. Now, you might say, right, hi, and how do I run this script? How do I do it? One way is to go func host start, and this one will spin up the same engine that we have on Azure. So this one's running the same thing. Exactly. There's no emulator, there's nothing else. And you'll notice that we have, so eventually, functions, we have our HTTP here. So if I grab that one and come on to, actually let's put a, so right now I'm not debugging, I'm just running it through the CLI. And just to prove the point, I'll jump onto my browser. I'll put name equals my name because I self-promotion. And you'll see here that got hit. We've got some logs here saying function started, function ended, and so on. So let's leave that there. Let's go back into our Visual Studio codes. And then if I go into my code and put a breakpoint, and I can go into my debugger, so that's a built-in debugger to Visual Studio Code, and say attach, then parcel updated, fantastic. So you notice up here that we're actually bound to the Node.js code that's running there and the Azure runtime. And if I close that and go back, so we have a breakpoint. And if I go back here and run it again, notice it stopped. What? No. Oh, interesting. I don't think I've seen this before. Huh. That's so weird. I'm telling you, I've done the default creators update on my machine, and everything is broken. So rather than doing that, I can do, if I go back to Visual Studio Code, and if I go into my terminal, I can actually do a curl. Oh, do I have curl here? I might not have curl here. Demo failure here. There you go. So I don't have curl there. So curl, and then my parameter dot name equals test. Oh, there you go. I do have curl. Thank God for Windows Subsystem for Linux. So, okay, cancel that. You notice how we actually have a breakpoint here. Imagine if that was a blob event that was hit on our storage account. It would be the exact same thing. You would be getting the blob data coming down. You see I have a query, a parameter named, and I have the value there. So I can actually go and debug my code with F10, F11, and so on to actually see what the code is doing, and you can have the proper dev experience. Just for reference, in Google and AWS, both Lambdas and Google Functions, there are companies that have been spun up only to fill that gap, the ability to actually debug off the portal. We give you that integrated and into your functions experience. So you're welcome. I'm just kidding. I didn't even do that work, so I shouldn't be taking credit. Now, quickly jumping into Visual Studio, if you create a file new project, then from there, you need to select something like cloud, and then you want Azure Functions. I'll leave that as default for the name. That gives you the actual function up. That's the cell again. That's where we want to host our function code. We don't have any functions yet. So once that's up and visible, there you go. Very similar to what you remember what we did with func init, the exact same thing. This one actually defaults to C#, just to be aware, out of the box. So there's a specific NuGet package for functions. And now if I want, I can go and once that's completed, taking sweet time, you can go and do an add new item. And they've changed the name. I'd say they changed the icon, by the way. So I was doing a demo the other week, and I was going up and down trying to figure out why it's not there. It's just up here. So you can name that whatever you want. You can say demo func, and I can click OK on that. Now the next one is it will pop up with the options on which trigger I want to use. You might notice that we don't have everything here again. There's a little bit of discrepancy as we change the tooling, but by default, if I go with an HTTP trigger, you can define what the kind of access rights, so you want to have an API key or not. You can leave it anonymous. Doesn't really matter when you do local testing. It really matters when you do the deployment on the live environment. And let me just hide that. Again, this is exactly the same code that we had on the portal. And I can go and kick this off. I think the first time I ran it last week on my demos, it failed, and I rerun it again, it worked, just to drive Vast insane. But what this will do is actually call into the core tools, spin up the function runtime, and run your application. So eventually, there you go, it's running. It will give us the runtime and the API endpoint that we could call into. I think I'm running another one, am I not? Yes, I am. And it might not be able to bind into that now. That's fun times. So let's see if it did it. Just thinking about it. There you go. So I think it's because I actually bound into that SendGrid. There you go. So now we have our API endpoint here. And notice that we always bind to the port 7071. So if you have another process running like I had before, it wouldn't let you. It doesn't let you spin up another process. So if you copy that, you can come back into the code. We're actually debugging now. So let me just put a breakpoint here. Jump onto here. Put a parameter there. Name equals Dave in honor of my host. And then there you go. You have the breakpoint hit there, full dev experience, full debugging, and then from here you can actually go and do something like right-click, publish. Please do not do that. I'm just kidding. You can do that. Nothing's stopping you. But if you're actually developing enterprise scale or you're working in a company, you can do full CI/CD. I wouldn't like to see anyone doing that. But if you want to, just to quickly test stuff, you can use that to publish straight into an Azure function app on the portal. And that takes us to 45 minutes after the hour. Dave, do you want to carry on or do you want to stop here? What's the preference?
Up to you guys. You want to carry on?
Shall we move into questions? Because I can speak for that for hours, to be honest.
Yeah, okay.
There's lots of content to cover. So I think I gave you a really high-level overview of what the tools are and how you can quickly spin up APIs without too much effort. Any questions on these things?
Okay. Anybody got any questions?
I've seen that a lot of this functionality is kind of like moving quite quick. Yeah. I don't know whether we've seen a few things that you showed in preview. I don't know whether is there a roadmap. Anyway, I know there's a conference next week, isn't there? To Connect. I don't know whether any more of it will reveal. Or is there a roadmap that you can do?
Did you hear that, Christos?
No, can you relay back? Because there was a little bit of background noise.
Okay, so it's all moving very, very quickly.
Mm-hmm.
With new things being announced all the time. Is there a sort of roadmap and times and definitions so that we can actually start a plan when we can put things into production?
Yeah, the team is moving very, very fast. I have to say that. That's frustrating for me as well, considering that I'm changing my content every 2 weeks. We are working on a public roadmap. The big features that they have, some like, for example, they announced proxies as a preview earlier on the year, and they did say that they should be completing the proxies as in GA by the end of the year. I think they're about there to meet the target. The team is aware that they don't really have lots of visibility in terms of what's been fixed and what's been worked and what the longer-term roadmap is. But they are going to make that more visible to you guys. They are aware of that. By the way, everything is on GitHub. So if you go on GitHub, both for the core tools I was demoing or for the runtime, you will notice that everything is done in the open space. So if you know your way around GitHub, you can find or you can understand where most things are in terms of the roadmap and completion times. But in general, Microsoft teams or product teams don't like to commit to dates. But if there are any specific questions about features that are missing or features that you're working on and you're not really confident about, feel free to reach out to them through GitHub or reach out on them on Twitter using the Azure Functions hashtag or @ or reach out to me and I'll relay that information. Trust me, I'm doing that almost on a daily basis.
Okay. Thank you.
But we did just undergone the biggest change, which was moving to the cross-platform tools, because in the past we had a CLI, but it will only run on Windows because they had a dependency on the .NET 4.5 framework. Now that's been lifted, so you can run anywhere. And that was the biggest change. You'll probably see a lot more languages added as well. So we just added Java. There's other languages in the works as well. So a much bigger ecosystem there to support and much better performance as well.
So what's the current state of the API proxies? That's just in preview at the moment.
It is in preview in the moment. So we have so the team tends to align GAs with conferences and events, and I suspect that some of the biggest GA items will be announced at the Connect conference in 2 weeks' time.
So 2 weeks. Okay. That's interesting.
By the way, if you are trialing any proxies, so I show you the demo, the stats there for Boeing, for example, then be aware that if there is any concern or anything else with regards to previews, you have the full support for the team. If you want to go into or sell it to your management, for example, then we can give you some more details on the roadmap and stuff. So feel free to reach out to us if you have any concerns that's stopping you or becomes a roadblock to your adoption.
Okay. I think we can wait 2 weeks, see what happens. Yeah. Okay. Any other questions?
I was just asking about authentication.
Question about authentication. Go on.
Yeah.
You mentioned about like you providing API keys. What about things like tokens? So if I was to build the back end completely in functions, so the user logs in by function, and then I need to pass that token and authenticate that token into calls, is it doing that?
Is there an overall mechanism for being able to write effectively the whole application in functions?
Yeah.
So that you can handle the authentication and pass an authenticated token between different functions when the same user has logged in and then makes further calls?
So you can use SSL certificates like we use for everything else. So if you go into the platform features, you can have SSL for your functions. We have function keys that are applied at the function level. And then you can have things like cores that protect you from, so you can have a function that only accepts a request from another function. So that will be done through cores and enforcing that. And then you can use, you can also use custom authentication if you want to. We also have Authentication Authorization here, which is called EasyAuth. And then once you enable that, it allows you to create specific authentication models for your, or choose what model you want to use, and you can use that. If you are concerned about not making your functions public because you want to run them internally, there is work happening to provide VNet support, so you can stick them behind a VNet and close off access to everything else outside your VNet and only give access to specific IPs or specific services. So there is a lot of there are a lot of different features. It depends on what you need to do, what you try to achieve, or what your scenario is. And based on that scenario, we can give you a couple of options. So if you have something specific in mind that is stopping you from, or you don't know how to solve, then again, feel free to reach out to us, and we can help you out.
Okay, so what sort of models of authentication are we talking about? Are you doing sort of basic authentication and the old web stuff like that, or what?
You can go all the way to to OAuth if you want to. You can use Azure AD to stick stuff in the front. You can use the API key if you just want to have just very simple stuff, but obviously whoever has the API key can hit your API, so not very secure. Again, once you turn the app service authentication to on, it gives you all the options to see how you do it. And then you can use a front-end function, for example, to do your authentication, and then pass that token around if you need to pass it. Again, as I said, lots of different ways to solve the same problem. It just depends on what kind of criteria and requirements you have.
Okay. Okay. So it'll be interesting to see if some sort of sample applications come out that show you these sort of things. I guess they're in the works as well. That sort of stuff.
You mean like customers solving problems like that on their environments?
Yeah, just a sample thing saying, hey, I need to do auth on all the requests that are coming in from this user to make sure that they're in the right role, etc. Because normally, if you've got your monolithic app, that's all handled and everything talks to itself because it's all part of the same thing. But in this case, we need to be able to move those tokens around between different functions, or as you said, have a function up front that does that first, authenticates the user, and then calls all the other functions behind it. So it'd be good to see if there's some sample things coming out on that.
I can have a look. I can have a look and probably put them into some link I'll provide with the slides. Now the slides have more information there. I didn't really have enough time to cover everything, as I said. But I'll share the slides so you can have a look. And if you find anything that I haven't covered or you have any questions, then feel free to hit me up.
Okay, that'd be great. If you can let us have the link to the recording and to the slides, I'll push that up to onto the meetup group for all the people that got stuck in traffic tonight. So I hope we got that.
Sounds good.
Okay. Any other questions? We're all good? Thank you very much. I find it very interesting, the API proxies in particular. That's something I'm struggling with at the moment. And in fact, goes into production, that's going to make my life an awful lot easier with the stuff I'm doing right now. So that's very good. Thank you for taking time to do this and making it all happen, even though you're in Glasgow instead of Birmingham. So can we give a round of applause?
Thanks, everyone. Have a lovely night, and thank you for having me. It's always a pleasure. And hopefully next time I'll be in person and we can share a drink afterwards.
Okay.
Have a lovely evening. Thank you.
Okay. Take care, Christos.
Thank you. Bye.